Skill is something you develop by doing. Curiosity is the real engine. If you are curious, your brain stays young and a young brain learns fast. Curiosity is when your brain says, "What is this?" and your heart says, "Let's find out." And don't wait for the talent, just start with the curiosity and follow it like a GPS. And now, coming to today's topic, it is on test of significance of small samples. Generally, there are two tests here. The first one is the student T test and the F test here. So, here is an example 7. The nicotine content in milligrams in the two samples of tobacco were found to be as follows. This is sample A and this is sample B. So this is the data given from sample A as well as sample B. And can it be said that the two samples have come from the same normal population? So we have to find out whether the two samples have come from the same normal population. So here is the solution. To test whether the two samples came from the same normal population, we have to test the equality of the variances using F test and the equality of the means using student T test. So here in sample A, N1, 2, 3, 4, 5, the sample size N1 is given as 5, and in sample B, 1, 2, 3, 4, 5, 6, the sample size N2 is given as 6. And next one, calculation of the means and the standard deviations of the samples. So here is the table here. X values are taken from this, that is 24 till 25 in column 1, and the next one here we have to make an addition, that is 123. So x bar is nothing but sigma x by n1, that is 123 by n1 is nothing but 5, that is 24.6. So in the third column, that is x minus, second column x minus x bar. So for each and every value of x we have to subtract 24.6. So that is 24 minus 24.6 is 0.6. 27 minus 0.6 is this one is 2.4. 26 minus 24.6 is 1.4. Like that we have to fill the second column and we have to make the squares. So using your calci, you can use your calci for making squares. That is 0.6 whole square is 0.36, 2.4 square is 5.76, and so on. So we have to make an addition, that is 21.2. Sigma x minus x bar whole square is nothing but 21.2. Likewise, sample B. So these are all the y values. So we have to post it in column 4 and we have to make an addition, that is 174. So this is 123. 174. So in order to get the y bar value, see here, y bar is equal to sigma y by n2. Sigma y is nothing but 174 by, what is n2 here? 6. If you divide, the value here is 29. So from each and every value of y, so we have to subtract 29. That is 27 minus 29 is minus 2, 30 minus 29 is 1, 28 minus 29 is minus 1, and so on. We have to fill this column, we have to make of squares and we have to make an addition. So for variance, for finding the variance, we have to do all these. So S1 square is equal to, see, first one S1 square is equal to sigma x minus x bar whole square by n1 minus 1. What is x minus x bar whole square? So this is x minus x bar whole square. The total is 21.2. And n1. So what is n1 here? n1 is equal to 5 and n2 is equal to 6. n1 is equal to 5 and n2 is equal to 6. So here n1 minus 1. 5 minus 1, the value here is 4. The value here is 5.3. For S2 square, sigma yi minus y bar whole square by n2 minus 1. So the total here is y minus y bar whole square. The summation here is 108. 108 by n2 minus 1. 6 minus 1 is 5. The value here is 21.6. So here for F distribution, this is S1 square and S2 square. So which is greater value? So S2 is greater value. So for F distribution, so we have to, whichever the value is greater, we have to keep it in the numerator. And for T test, see here, test statistics, F is equal to S2 square by S1 square. If S1 is greater, so we have to change the formula as S1 square by S2 square. So here in the present formula here, S2 square is greater. Therefore 21.6 by 5.3, the value here is 4.075. Here the calculated value is 4.075. And now we have to check in the tabular value. So for tabular value n2 minus 1 comma n1 minus 1. So here what is n1 here? So generally n1 minus 1, n2 minus 1. So here this is 4 comma, so this is minus 1 minus 1, that is 4 comma 5 at 5% level of significance. So here I am going to check in F distribution table. So here is the F distribution table. N1 minus 1. So what is N1 minus 1? This is 4 and this is 5. So in 4 and 5, the value here is 5.19. The value here is 5.19. Generally, we'll see at 5.19 or 6.29. So for both the values, this value is lesser. So since the calculated value of his SF is less than the tabular value, so we have to accept the null hypothesis H naught, and sigma 1 square is equal to sigma 2 square. And see here, we are going to use the student t-test. And now for the equality of the means, we are going to test the student t-test here. Sigma xi minus x bar whole square is equal to 21.1 and sigma yi minus y bar whole square is 108. So remember from the... See, this is the student t-test. The two means are equal. First one is mu1 equal to mu2. Here x bar is equal to 24 from the table and y bar is equal to 29. So x bar is equal to 24.6 and sigma xi minus x bar whole square is equal to 21.2 and sigma yi minus y bar is equal to 1.8. For s square, the formula is this one, that is sigma xi minus x bar whole square by yi minus y bar whole square by n1 plus n2 minus 2. And see here, n1, what is n1 here? N1 is equal to 5 and n2 value is equal to 6. So sigma xi minus x bar whole square is 21.2. 21.2 plus 102 by, this is 5 plus 6 minus 2, the value here is 14.35. So as the calculated value is 3. So this is the variance S square. So if you make a square root, the standard deviation will be root over 14.35. The value here is 3.78. For test statistics, this is the formula here. For test statistics, T is equal to x bar minus y bar by S into root over 1 by n1 plus 1 by n2. What is x bar here? X bar is nothing but 24.6. Y bar is nothing but 29 by S. S value here is 3.78 root over 1 by n1. So 1 by n1, 1 by 5 plus 1 by 6. The value here is minus 1.92. So after taking modulus on both sides, the value here is 1.92. At C here, n minus 1. So for degrees of freedom, so we have a formula for degrees of freedom as n1 plus n2 minus 2. So here this is 5 plus 6, 11 minus 2. The value here is 9 degrees of freedom. At 5% level of significance, we have, I'm going to show you the T distribution table. For T distribution table, this is 9 at 0.05. The value is 1.833. So here, the value here is 0.0, this is 2.26. So here n1 plus n2 minus 2 at 9 degrees of freedom at 5% level. So at 9 degrees of freedom, at 5% level, this is 2.262. The value here is 2.26. So this is the calculated value and this is the tabular value, that is 1.92 is lesser than 2.26. As the calculated value is less than the tabular value, so we have to accept H naught. And what is the conclusion here? The two means are equal. So from 1 and 2, we conclude that the two samples came from the same normal population. For equal variance, we have to go with F test, and for equal means, we have to study with the student t-test. And this is how we have to solve. And the next question here is also very, very important. So this is also repeatedly asked question. The measurements of the outputs of the two units have given the following results. Assuming that both the samples have been obtained from the normal populations at 10% significant level, test whether the two populations have the same variance. If it is asked for same variance, we have to choose F test. Unit 1 and this is unit 2. See, as usual, for a null hypothesis, sigma 1 square is equal to sigma 2 square, and alternate hypothesis, sigma 1 square not equal to sigma 2 square, and here n1 is equal to 5. 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. Clearly n1 and n2 is equal to 5. And x bar is equal to. So we have to make an addition out of these. And this is a 66.6. And this addition is nothing but 69. 66.6 by 5. So this value is 13.32 and y bar. So we have to make an addition, that is 69 by 5. The value here is 13.8. So you have to use your calci. So after getting the mean value as 13.32 and y bar as 13.8, so this is the table here. So from the table here, So these are all the values, so which we have to use in the column 1 as x and x bar. So we have to subtract each and value of x from this one, 13.32. That is 14.1 minus 13.32 is 0.78, and 10.1 minus 13.32 is nothing but minus 3.322. And like that we have to fill this, and we have to make the squares out of this, and we have to make an addition out of this. That will be sigma xi minus x bar whole square. And y column from unit B. So this is the unit B from 14 till 14.1. So we have to fill in the fourth column, y bar. So just now we found that y bar is equal to, this is 13.8. We have to subtract each and every value from 13.8. So this is 14 minus 13.8 is 0.2. And next one, 14.5 minus 13.8 is 0.7. So we have to fill this column, and we have to make a square. And now we have to make an addition out of this. And now one, if s1 square and s2 square be the estimates of sigma 1 square and sigma 2 square, s1 square is equal to sigma xi minus x bar whole square by n1 minus 1. Clearly n1 value is equal to 5 and n2 value is also 5. So here the addition here is 13.488 by 5 minus 1, this is 4. The value here is 3.37372. And s2 square is equal to sigma yi minus y bar whole square, that is 1.84 divided by n2 minus 1, 5 minus 1, this is 4. The value here is 0.46. After observing both the values, which one is smaller or which one is bigger? So this one is the bigger. If it is bigger, it should be in the numerator. So here is the test statistics formula. If s1 square is greater than s2 square, the formula here is f is equal to s1 square by s2 square. Whichever it is bigger, it should be in the numerator, and therefore 3.372. So this is 3.372 by 0.46. The value here is the 7.33. Clear? F value, calculated value is the 7.33. And now for the degrees of freedom here, n1 minus 1, n2 minus 1, that is 4 comma 4. At 4 comma 4 at F distribution, see here at F distribution, let's see. This is F distribution table at 4 as well as 4 here. The value here is, so this is 4, this is 4, this is a 6.39. The value here is a 6.39. So this is the calculated value and this is the tabular value. And it is very clear that the calculated value is greater than the tabular value, and therefore we are going to reject the null hypothesis. And what will be the conclusion? There is a significance difference between the variance. And this is how we have to go. Next one is problem number 9. So this is problem number 9. The following random samples are the measurements of the heat producing capacity in millions of calories per ton for specimens of coal from the two mines. So this is mine 1 and this is mine 2. So these are all the data given. So here use 0.02 level of significance to test whether it's reasonable to assume that the variances of the two population samples are equal. So here if you observe, this is sample 1 is nothing but 1, 2, 3, 4, 5. So n1 is equal to 5 and n2 is equal to, see here, this is 6. So this is the data obtained. As you can see, this is mine 1 and this is mine 2. So all the values from x are placed in column 1. So this is the total here. So this is the total here. And see, x bar is nothing but sigma x by n1. That is 41,150 by 5. This is 8230. So 8,230. So from each and every value, so we have to subtract 8230. That is 8,230. The value here will be, if you subtract, the value here is 30. 8130 minus 8230 is minus 100. And 8350 minus 8230 is this one. So we have to fill the column here and we have to make a squares out of this. 30 square is 900. Minus 100 square is this one. So we have to make a total out of this, that is sigma xi minus x bar whole square. And this is the total. And the next one is y bar. So this is the second column from the table here. So after making an addition, so this will be the addition value, and y bar is equal to sigma y by n2. So n2 is equal to 6. That is 47,640 by 6. The value here is 7,940. From each and every value we have to subtract 7,940. That is 7,950 minus 7,940 is 10. So likewise we have to subtract each and every value from this one. That is 7,940, and we have to make a square. And next one we have to make an addition. And see here, S1 square is equal to, so this addition, that is 63,000 by N1 minus 1. So N1 is here is 5. 5 minus 1 is 4. The value here is 15,750. S2 square is nothing but sigma y minus y bar whole square. The total here is 54,600 by N2 minus 1. So here N2 is equal to 6. 6 minus 1, 5. The value here is 10,920. So when you compare which one is greater, this value is greater. So as usual, for null hypothesis, S1 square is equal to S2 square. For alternate hypothesis, S1 square not equals S2 square, and level of significance alpha is equal to 0.02. Test statistics, whichever it is greater, so we have to keep it in the numerator. Here the formula changes as S1 square by S2 square, that is 15,750 by, so here 10,920. The value here is 1.44. So this is the calculated value. So here in the conclusion part, the tabular value of f at 4 comma 5 degrees of freedom at 5% level of significance here is, so in f distribution generally at 4 and 5, so at f distribution at 4 as well as 5, the value here is, this is for 4 v1 and this is v2 5, the value here is 5.19. So this is 5.19 from the table. So at 2% level of significance, the value is greater than 5.19. So here, this is the calculated value. So this is lesser than 5.19. And therefore, we are going to accept the null hypothesis H0. And therefore, the variances of the two population samples are equal. So this is how we have to check. And next one, going to 10th question here. In one sample of how many observations? 10 observations. So here N1 is equal to 10. The sum of the squares of the deviations of the sample values from the sample mean was 120. And in the other sample of 12 observations, it was 314. And now what is it we have to test? So we have to test whether there is a significant difference at 5% level of significance. The first one, we are going to take the null hypothesis. As usual at null hypothesis, sigma 1 square is equal to sigma 2 square. And for alternate hypothesis, sigma 1 square not equals to sigma 2 square. See here, for alternate hypothesis, sigma 1 square not equals to sigma 2 square, as s1 square is equal to sigma x minus x bar whole square by n1 minus 1. So here, if you see, n1 is equal to 10 from the question, and sigma x minus x bar whole square is equal to the sum of the squares of the deviations of the samples from the sample mean is, first one is 120, and the next observations here is n2 is equal to 12 observations, and the next one is the sigma y minus y bar whole square is 314. So this is the data from the question. See here, from this S1 square formula here is sigma xi x minus x bar whole square by n1 minus 1. So this is the formula, and s2 square is equal to sigma yi minus y bar whole square by n2 minus 1. So n1 is equal to 10 here, this one 120 by 10 minus 1, the value here is 13.33, and s2 square is equal to 314 by 12 minus 1. As this is the formula here, if you substitute, the value here is 28.54. So among these two, which one is bigger? This one is bigger. And now S2 square is greater than S1 square. Clear? And therefore, our test statistics formula changes as S2 square by S1 square. The test statistics formula is, which is bigger? That should be in the numerator. That is 28.54 by 13.33. The value here is 2.14. So here, at degrees of freedom, n1 minus 1. So 10 minus 1, 9, and 11, 12 minus 1 is 11. That is, this one is 9, 11. At 9, 11, at F distribution at 5% level, see here, let me show you the F distribution table. So this is the F distribution table, V1. So these are all the V1 values. At 9, we have to check. And next one, this is at 11. 9 and 11, the value here is 2. So this one is 2.90. So the value here is 2.90. Since this is the calculated value and this is the tabular value, 2.1 is lesser than 2.9, and therefore, since the calculated value is less than the tabular value, and we can accept the null hypothesis H0. And what is the conclusion part? And we conclude that the difference is not significant at 5% level. See, and the next question here is, an instructor has two classes. So how many classes are there here? Two classes here, class A and class B. In a particular subject, class A has how many students? 16 students. N1 is equal to 16 and B has 25 students. On the same examinations, although there is no significant difference in the mean grades, the class A has the standard deviation of 9, while class B the standard deviation has 12. So now can you conclude at 0.01 level of significance the variability of class B is greater than that of class A? So first of all we have to take the data. So here, significance of variability. So again we have to go with null hypothesis. Sigma 1 square not equals to sigma 2 square. Clear? And the next one, alternate hypothesis, sigma 1 square greater than sigma 2 square. And S1 square is equal to N1 S1 square by N1 minus N. So what is N1 here? N1 is equal to 16. Class A 16 and for class B 25. And next one, standard deviation here. The standard deviation S1 square. Standard deviation S1 is equal to 9 here, while as the standard deviation S2 is equal to 12. So this is the data from the question here. So S1 square, that is the population variance, is equal to N1 S1 square by N1 minus 1. So if you substitute, that is 16 by 16 minus 1 into S1 square, that is 9 square 81. The value here is 86.4. And for S2 square, the formula here is N2 by N2 minus 1 into S2 square. What is N2 here? 25 by 25 minus 1 into S2 square is nothing but 12 square, that is 144. The value here is 150. So among these two, which is greater? S2 is greater. So S2 value is greater, and therefore for test statistics F is equal to S2 square by S1 square, as S2 square is greater than S1 square. 150 by 86.4, the value here is 1.736. At degrees of freedom, V1 is equal to N1 minus 1. 16 minus 1, the value here is 15, and V2 is equal to N2 minus 1, that is 9 minus 1, sorry, N2 25. 25 minus 1, the value here is 24. At 15 comma 24, so we have to check the level of significance. See here, the level of significance is 2.89 from the table. So here the calculated value I am showing, the calculated value here is 1.736. 1.736, and this is the tabular value, and clearly the calculated value of F is less than the tabular value, and therefore we accept the null hypothesis at 1% level, and therefore the conclusion part here is the two variants A and B are the same. Clear? And the next one, the last question in this topic is here, the 12th question. The two independent samples 8 as well as 9 items respectively had the following variables. So this is sample A and sample B. Do you estimate? Do the estimate of the population variance differ significantly? If it is asked about the variance, we have to take F distribution table. So here, as usual, null hypothesis, sigma 1 square is equal to sigma 2 square. Alternate hypothesis, sigma 1 square not equals to sigma 2 square. And so this data is filled in as this one, column 1. See here, from 9 till 14, copy in column 1, and we have to make an addition, that is 96. And next one, N1 is equal to 1, 2, 3, 4, 5, 6, 7, 8. N1 is equal to 8 here. And see here, x bar is equal to sigma x by N1. What is sigma x? 96 by 8. The value here is 12. So from each and every value we have to subtract 12. That is 9 minus 12 minus 3, 11 minus 12 minus 1, 13 minus 12 is 1. So we have to fill this second column, and we have to make squares out of this. Minus 3 square is 9, minus 1 square is this one. And we have to make an addition, that is 36. And the next one, from sample 2, from 11 till 10. So copy in the fourth column, and we have to make an addition. This will be y bar. Y bar will be 77 by 7. Here N2 value is equal to 7. So N2 value is equal to 7. The value here is 11. From each and every value subtract 11. 11 minus 11 is 0. 13 minus 11 is 2. 11 minus 11 is again 0. 14 minus 11 is 3. And we have to make the squares out of this, and the value here is 24. So here we got 24. And this is nothing but, so sigma xi minus x bar whole square value is 36, and sigma y minus y bar whole square value is equal to 24. So this column total is 36, 24. See here, for S1 square, sigma xi minus x bar whole square by N1 minus 1. This is 36 by What is n1 here? N1 is 8. 8 minus 1, 7. The value here is 5.14. And S2 square is sigma yi minus y bar whole square by n2 minus 1. 24 by, what is n2? 7 minus 1, 6. The value here is 4. On comparing these two, which is bigger? 5.14 is bigger. And the bigger value should be in the numerator. So for test statistics, see here, f bar will be s1 square by s2 square, that is 5.14 by 4, the value here is 1.285. So for degrees of freedom, n1 minus 1 and n2 minus 1. What is n1 here? So n1 is 8 and n2 is equal to 7. So n1 is equal to 8 and n2 is equal to 7. That is 7 comma 6. At 7 comma 6 at tabular value, for as f distribution, first one is a 7, so we have to go with 7, and next one we have to go with 6. 7 6, that is 4.21. The value here is at 5% level of significance, the value here is 4.21. So this is calculated value and this is the tabular value. As you can see very clearly that the calculated value is less than the tabular value. And next one, at 5% level of significance at 7,6, we accept the null hypothesis and we conclude that there is no significant difference. So even though it is a lengthy video, so many questions are, most important questions are uploaded into your brain, and please, it's your turn. The whole textbook is in your hands. So you have to prepare, score and celebrate. Thank you so much for watching. If you really like, you know what to do. Please subscribe and pass it on to as many friends as you can. That is the greatest help needed to this channel. Thank you.